Hi, this is Don't Imitate, Understand. I'm Tony Elisea. In this video, we'll endeavor to gain a proper mental model of promises, async, and await in the JavaScript programming language. In order to do that, we'll first start by reviewing some fundamental things we need to be sure we understand in order to then understand promises, async, await, and dealing with asynchronous processes in JavaScript in general. For starters, we need to know that functions in JavaScript are first-class objects. That means they can be assigned as values and passed around. So we could write something like this. A function that takes another function as a parameter, in this case other fn, does some work and then executes the function that it's been given. So I could call run this and give it a function to then run. I could do that again with a different function. So this function again is being passed around. It's a first-class object. I might also rewrite this using arrow functions like this, but it's the same idea. I have a function that takes another function as a parameter and runs it. So when I call run this, what's being passed is this function object. And we refer to this concept and the function itself being passed as a callback. We've given it to a function, and then it calls that function in return. And this happens again with a different function object. After it's done and it actually runs, we would get output that looks like this. The run this function's been run twice, and each time it ran the callback. That's the first concept. The second concept is how JavaScript is actually executing its code under the hood. Under the hood of the JavaScript engine is an execution stack. On the execution stack are placed execution contexts. Where your code begins is the global context. And as functions are called, they're placed on the stack. If function 1 called another function, let's say function 2, that would also be placed on the stack. And when that function is done, then that execution context is removed from the stack. As part of this concept also is how JavaScript is running each of those individual execution contexts. If we looked inside one of these functions, we could see that essentially the JavaScript engine is executing each line of code individually, one at a time. Because JavaScript is synchronous and single-threaded, which essentially means that it's doing one thing at a time. But we know in practice that when we're writing JavaScript code, there's often multiple things happening at the same time. How is that actually going on? The JavaScript engine provides the idea of a queue, essentially a spot to put notifications that things outside the engine have occurred. Things that, in your code, you might be interested in. And when we say outside the JavaScript engine, it's because how the JavaScript engine is generally used in practice. In reality, this entire concept sits inside the JavaScript engine, which for most engines is C or C++ code. And those engines are in turn embedded in other systems, also usually written in C or C++ code, like internet browsers, or Node.js. And that's where these other things, these other processes are running that might be happening at the same time that the JavaScript engine is processing its code, and then might notify the engine that some work is done. For example, a common feature in browsers and in Node.js is the idea of a timer, something that can count down and then do something once enough time has passed. Now, this concept does not exist inside JavaScript itself. It's not part of the JavaScript specification or JavaScript engines. But since JavaScript engines are usually embedded inside a larger system, that larger system can give features to JavaScript that it normally wouldn't have. For example, for years, developers have used something called setTimeout. But setTimeout doesn't exist in JavaScript. It's not inside the specification. It's a feature made available to JavaScript from whatever system it's embedded inside of, usually the browser or Node.js. And then we can use the concept of first-class functions to specify a function that should run when that external process is completed. And when that process is completed, a notification of that can be placed on the queue, and the JavaScript engine then knows what to do. If we zoom back in, once this other code has been completed, the JavaScript engine can look at this queue, understand that it needs to be processed, and run the associated callback function. In modern JavaScript engines, it's a little bit more complicated than that, in that there's actually multiple queues depending on what might have greater priority. But from a mental model standpoint, this is enough to understand what's going on. And again, this is our callback. Now, once we start writing code like this, where we're initiating the use of a feature, providing a callback function, and then doing something inside that function, we begin to find ourselves in a bit of a quandary, a bit of a difficulty when it comes to coding. Because I might have several things in a row that require waiting for that external process to complete. And I might get code that looks like this. Let's imagine that I set a timeout. When that timeout was complete, I had to go out to the internet and get some data, like a person. That's going to happen through the browser, for example. That's not part of the JavaScript engine. So JavaScript requests that. It's going to be another process external to the engine, which means we're going to wait again. And then perhaps once we get that person information back, I have to go out to the internet again and get another set of information, like get log. And so we end up with this nested set of callback functions. This actually gets really difficult to deal with just from a writing code and debugging standpoint, from looking at it and understanding what's going on, especially when it gets big and there's lots of logic involved. In fact, sometimes this coding structure is called the pyramid of doom, because if you look at it sideways, well, it kind of looks like a pyramid. There's a couple of other problems with this coding structure. Let's suppose that we process the event and the callback runs. Now the event is over. But what if we had multiple callbacks that we wanted to run when that event completed? Where would we specify that? Another problem is, what if the event is processed, it's handled, and then later we say in some other function, whenever that process completes, I also want to handle it. But the process is already completed, so what do we do? These are problems not solved by this coding structure. But I bet if you stopped and thought about it, you could start to imagine ways you could code it to be able to handle those problems. It's not that JavaScript can't handle those problems. It's that this basic, simple idea of callbacks within callbacks doesn't handle that idea very well. We need a better concept, a better coding approach to dealing with asynchronous events. And that's where the idea comes in of a promise. A promise is a standardized approach to dealing with asynchronous events and callbacks. Now, sometimes we hear things said that sound kind of complicated, kind of deep. Like JavaScript has promises now, or some feature returns a promise. But that's nowhere near as complicated as it sounds. It's really just an idea. Let's illustrate with a simpler idea. Let's suppose that around the world, JavaScript coders everywhere were dealing with people. That is to say, data about people. And so these objects and data represent a person, a human individual. But many JavaScript coders were doing their own implementations of very similar ideas. Maybe one uses a person object. Another one uses a human object. Another one uses an individual object. They all basically do the same thing, but they're not quite the same. And that makes our life a little difficult. So everyone gets together and says, let's come up with one specification for what a person object should look like. And we'll all use that same person object. When we do that, that makes all of our lives easier, and we can write tools and utilities and share code, and everyone's life is better. Then the folks that write the JavaScript engine say, great, It's in the specification, so we'll add it into the engine. We'll make this object available. And so people start saying, JavaScript has persons now, or some feature returns a person. It doesn't really mean that JavaScript can do something new that it couldn't do before. It means that there's now a standard that's available in JavaScript so that you don't have to write it yourself, and that we all know we're using an object that is the same object. It's really a simple and useful idea. In the exact same way, promises are an object that represent an idea. A promise object represents a future value, a value we know eventually we're going to get, but we may not have yet. It encapsulates this general idea that we've already seen when it comes to the JavaScript engine being embedded in another system that provides other features. So that system provides a feature, and it provides some hook for JavaScript coders to request the use of that feature, and a way to run a function when that feature has completed its work. When that work is completed, we assume that we have some kind of value, maybe some data coming back from some other system, a true or a false, whatever the case is. We have some value in the future, and a promise represents that value. But it also wraps up the idea of requesting the usage of that feature and handling it when the feature has completed its work. And again, these aren't things that the JavaScript engine couldn't already do. But coders wanted to encapsulate this idea, standardize this idea of an object that represents a future value. And there were other implementations out there in the past. But then it became part of the JavaScript specification, and JavaScript engines implemented a standardized version of the idea, a standardized object. And that object is a promise. Now, to understand promises and what they do, we're going to start by coding just a little bit, the first half of our own version of a promise, to get under the hood a little bit and understand the ideas. Then we'll use the implementation of promises in JavaScript to understand more. Then we'll use that to understand async and await. So let's write a little bit of code that shows how a promise object is supposed to work. Now we'll say right away, don't use any of this code we're about to write. We're going to focus on simplicity, so we understand the ideas. But that means this code will not be ready for use in production, and you don't really need it because a promise object is already available in JavaScript. So let's write the beginnings of our own promise object. To start with, we think about what it's representing. It's representing a value that comes back after work is completed. So there's three states that we want to think about. There's the state where the work is pending, the state where the work has been fulfilled, that is, it's done and completed successfully, and the state where the work tried to complete but couldn't. There was some problem, some error, and we'll call that rejected. The promise then will be in one of these three states. We're waiting for work or pending, the work is done and we have a value successfully, which is fulfilled, or the work did not complete successfully and we probably have an error message, which is rejected. Now let's create our promise object. I'll call it custom promise. And what we'll give it is an executor function. What does that mean? It means the function that will actually do the work that we're talking about, that will request the data from the database or run a set timeout. A promise object doesn't actually do any of the work that we've been discussing. A promise object wraps up the idea of waiting for that work to complete and then figuring out what to do after the work is completed. It's up to the coder who's using the promise object to actually write the executor function that does the work and then give it to the promise. And then the promise will run it. The first thing a promise needs is its current state. We'll start that off always as pending. We're waiting for the work to complete. Then here's the big important one. That value that we're waiting for. It starts off as null, but we know that eventually we'll have some kind of value or perhaps an error message. Then we'll deal with one of the first problems we talked about. Perhaps I want more than one handling function, more than one callback to run when the work is complete. So I'll have an array of handlers. And maybe I need more than one function to handle things if something goes wrong. An array of functions that get called if there's an error. I'll call these catches. Now we add a very important function we'll call resolve. That means the work is done and I have a result, a resulting value. This function will get called by the executor. So we'll give this function to the executor, and that function, the executor function, the function written by the coder using the promise, will call the resolve function that's on the promise object and give it that value that it just received. Inside the resolve, I'll do something simple. I'll say, if we aren't pending anymore, then I'm not going to resolve. That means that promises are designed to deal with what's called one and done operations. Something that's only done once and then it's finished. So if it's not pending anymore, there's nothing more to resolve. The value will not change once it's been set. And that helps us make sure that our code works the way it should. If, however, we're still in a pending state, well, now we'll say, because you called resolve, I assume that the work is done. It's been fulfilled. And I'll set my internal value to whatever result the executor function gave to me. So now the work is done and I have a value. And the last thing is, can you guess? I need to take all the handlers and run them. So I'll say for every handler function in the array, I'll execute the handler function, and I'll give each of those handling functions that value that just came back. So now, this does the work. The work is completed, the promise now has that future value set, and all the callbacks are run. We can do something very similar if there's an error. I could say I have a reject function that gets an error. I'll never call it if the promise is already finished, but if the promise hadn't finished yet, I'll say, well, now you've told me that it's finished, and I know that it's been rejected. There's a problem. And I'll set my value maybe to the error message. And I'll say catches, and I'll call each of the error handling functions and give it that error message. Now here's one more function, and this is one you see a lot when using promises. .then. .then takes whatever the callback function is and does one of two things. Here we're going to again solve one of the problems that we talked about. If we call .then and the promise has already been resolved, that means we already know the value, whether it's fulfilled or rejected, then if the state is fulfilled, then we don't have to wait for anything. So we'll just execute the callback immediately, and we'll give it the value that we already know we have. If, on the other hand, we're still waiting, then we'll simply add the callback to the array of callbacks or handlers that we're going to execute when it's done. Now, I won't do the work of figuring out what to do if there's an error, but you get the idea. We're either executing the callback immediately, or we're adding it to the array of callbacks, which will be executed when the promise is resolved, when the resolve function is called. The last thing to do is what always has to be done when the promise is created. We run the executor function. A promise represents a process that's already running. So when we create the promise, that actually starts the work. The creation of the promise runs the executor function that we give it. And the executor function that whatever coder is using the promise object writes should expect a resolve and reject function. These two functions are passed to the executor function so it can use them when the work is completed or when an error has returned. And that's actually enough to demonstrate this first half of what a promise object is meant to do. Let's try using it. I'm going to create my actual executor function, a function that does some work. I know that I'm going to be given a resolve and a reject function when the promise executes this executor function that I'm writing. So now I'm going to do some work. I could just resolve it right away to some value to say the value is done. But we want to demonstrate what happens when you're waiting for work to be done. So I'm going to use setTimeout. I'm going to give setTimeout a function to run after 1 second. What that function will do is simply call resolve. Now, it might do in the real world a bunch of other work in order to get this final value, and then call the resolve function. Here, I'm just going to call it right away and say, hello world. So what happens is, when I create the promise, it will represent some future value, and I'll give it my executor function. Now remember what will happen. When this promise is created, I've given it an executor function. The state will be pending and the value will be null. Then inside my executor function, I call the resolve function that was passed by the promise, because the promise immediately executed my function and gave me the resolve and rejects so that I can call them. So I'll call resolve and give it the value hello world, which will end up as the value inside the promise object. And then every handler that I add using .then will be run. So let's add some handlers. I can say sometext.then, because sometext is the promise, and I'll say, well, give me the value that was resolved, and I'll just say let's output that to the console. Now remember, this is adding the function that I passed in to an array of handlers. So I can do this again. And I could say a second log function. And remember, now I'll just have handlers. I'll have 2 of them inside the array, and both will be called. And I could even add another handler after we know the promise has been resolved. Remember, we said that setTimeout after 1 second will resolve the promise. So I could say after 3 seconds, knowing that that's going to happen after the promise is done, to go ahead and do this again. And this should still work, because when that handler is added via .then, the state will be fulfilled, and it'll just call it using that hello world value that we've now resolved. So let's run this and see what we get. The first setTimeout, which resolves, then the next setTimeout, which adds yet another handler. And all 3 handlers run successfully using the resolved value. Why does this work? One more time. We created a function, our executor function, that does work and expects these functions from the promise. We call the resolve when our work is done. This function is immediately executed by the promise when the promise is created. Every time we call a .then, we're actually adding a handler to an array. And so that array is simply used when we actually have a value that we resolve. Any handlers added after the resolve is complete through this .then function is also simply executed. But it's executed right at that moment because there's nothing left to wait for. We already know the value. I hope this makes sense. A promise object represents a future value for a process that's already running. And .then lets us add handlers for when that work is complete and we know what that value is. We haven't added all the error handling and we haven't tried to make this robust, but this is the basic concept. It's a better coding approach to dealing with callbacks. And with promises in JavaScript, this coding approach is standardized. Now, inside JavaScript engines, the included promise object does get a bit more priority than some other external processes, but this is basically what it's doing, the exact same thing. The second half of what a promise does is where our coding structures get really interesting. What if I have a sequence of asynchronous processes and I want to avoid that pyramid of doom? What would be really great if the .then function did something really fantastic, if it returns a promise. Why is that great? Because if my callback also does something that requires us to wait for a returned value, I could then chain a sequence of thens. I could flatten the pyramid. All right, let's see what that really looks like by using the actual promise object that comes along for the ride in JavaScript. So here's the same idea, but using the promise object that's built in to the JavaScript engine. I have my executor function that's doing some work. We know that the promise will run this function, and when it does, it will pass in its own resolve and reject functions that I can then use. I'm going to set timeout and resolve the promise with a value. In the real world, this could be a success message or some data. I'm just going to say hello world. Then I create the new promise, giving it that executor function. Notice I don't have to do much here. The promise object is already available to me. And then I use the .then function to add a handler. And when I run it in the browser, after a second, the handler executes using the resolved value hello world. So we understand how this works. Now, what if I had another situation in which I wanted to do another piece of asynchronous work, but I wanted to do it as a result of the first? Let's suppose that I have another executor function. I'll just call it do other work, and it will resolve to a different string, maybe how are you, but it will do it after 3 seconds. Now I want this function to run, but I only want it to run after the first function is complete, after that first promise resolves. So how can I do this? Well, first we can understand a major important feature of the .then function in the built-in promise object. If my handling function returns a value, I'll return a string here. What does the .then function return? Again, my function returns a string. To find out, let's set a variable equal to the return value of .then. And what you'll see is that I can then do this. I'm going to go ahead and do a new .then, and I'll output to the console the value that's returned. What do you think we'll see? My function returns this string. The .then function returns another promise, which I then attach a .then to, a different promise. And there it is. Both .thens ran. Now, because of JavaScript's chaining ability, I can write this differently. I don't need to set this value. I can simply attach the next .then to the return value of this .then. But it's the same thing. Some people get confused when they see this. They think that 2 handlers have been attached to the original promise. But it hasn't. One handler has been attached to the original promise, and a new handler has been attached to the new promise returned from .then. So the built-in JavaScript promise object has a feature. When my handler returns a value, it wraps that value up in a promise so that I can continue this approach to coding my responses to the asynchronous processes completing, even though this value wasn't created asynchronously. But even better, what happens if I return a new promise with that other executor function, the one that I wanted to execute after the first executor function completed? What do you think should happen? Well, the second function executes after 3 seconds. So 3 seconds after the first one completes, that other handler completes, and we see both results, hello world and how are you. What's actually happened is very clever. My function returned a promise. The then function always returns a promise. The promise that it returns in this case is connected to or synced up with the promise that I returned. In other words, when the promise that I returned resolves, this new promise created by then resolves and will have the same value as the promise that I created resolves to. It effectively acts as if I'm adding a .then to this new promise. It's not quite the same because it's always adding to a new promise created by the .then function, but effectively this is what happens. So inside every .then, I could have a new asynchronous process occur, return a new promise, and the promise object's code will make sure that each .then is only run after the promise resolves. So we can have a sequence that works properly without getting into a pyramid of doom. We've flattened the pyramid. We would simply have a sequence of .thens, each .then attached to the new promise generated from the previous function's return. Now, in reality, you're not always going to be calling the resolve function yourself. Remember, the point of having a standardized promise object, or one of the points, was to be able to have utilities and tools that work using the promise object. And often you'll be using those utilities and tools which make use of promises, but this helps you understand what they're doing. Let's take a look at a slightly more realistic example. In this example, we'll use a feature called fetch. Fetch isn't a part of the JavaScript specification. It's its own specification. It's meant to be used in JavaScript, but implemented by those systems that embed the JavaScript engine inside of it, like a browser. Fetch goes out and does the work of going out to the internet and getting a file or some data or whatever the case is. In this case, we've made a little JSON file called video. It's an array with one object in it with a title. Fetch will go and get this information, and fetch returns a promise. But now we know what that means. The object built into JavaScript that wraps up a concept of how to deal with asynchronous events and callbacks. I'll have a .then, and I'll be able to use a special type of object that comes along with fetch for handling the response, a stream of data. And on that response, I can call .json, which parses that JSON string and converts it into JavaScript objects and arrays in memory. And guess what? .json returns, you guessed it, a promise. Now remember, this is just shorthand here using this arrow function for return response.json with this execution. So the shorthand function is returning the results of response.json, which is a promise. So I can call another .then. When this function is executed, that means that I'll have that final in-memory result when the JSON is parsed, and I'll output that to the console. What does that look like? Just what you would expect. An array that has one element, an object that has a property called title. Notice I haven't had to call resolve. That all happens inside the fetch feature, but we understand what's going on and how to use it. And it keeps my coding structure flat and easier to read, understand, and deal with. So, is that the end of the story? No, because JavaScript has another way to code, to write, to deal with asynchronous events and callbacks. It depends on promises. It relies on them, but it makes your coding life even easier. And it's called async and wait. So how does that work? Well, before we do that, I'd like to throw in one other piece of information, a thing that you hear when you hear promises, async, await being talked about that sounds really strange, but is actually a very simple idea. We've already seen that one of the points of having a standardized promise object is being able to have this coding structure of .then. Sometimes you hear people talk about Thenable objects. So what is that? A Thenable object? Big word alert. Thenable. An object that's thenable simply means, basically, an object that has a then function. And this has to do with coding something that goes beyond just the built-in promise. Let's say that we have a set of our own objects, or we're using a utility that has its own set of objects that act like promises or use them. We'd still like to be able to use this same coding structure. Suppose we have some promise and we add a handler on it using .then. We know we can chain these together, but let's suppose in reality we're using some custom object that isn't really a promise, but we'd like to keep using this .then structure. Essentially what we're saying is, if that object follows the same pattern of how a .then function works, it's thenable. So we can continue to use that same coding practice. And it's really no more complicated than that. All right, now that said and that out of the way, what about async and await? So here's our similar code again. I have two functions that will do work. They'll resolve a promise in each case. And I have a new function that I've written called do all the work. But we have a new keyword in front of the keyword function, async. Inside this function, we create our new promise and then await that promise with the keyword await, then output the results. We'll do the same again with the do other work promise, await that result, and output it. Then we call this function and output to the console that we're done. Now the console outputs, considering these are asynchronous processes, should result in done being seen first, then after 1 second, hello world, then after another second, how are you, if these two promises are resolved in order, if the second promise waits for this first promise to be done. When we run this, that's exactly what we see. So, what just happened? Well, we know what just happened we could already accomplish using promises and .then, using a coding structure that we could even make ourselves. We certainly couldn't add these new keywords to JavaScript, so these have been added as part of the JavaScript engine. Therefore, async and await are something that's called syntactic sugar. Big word alert. Syntactic sugar are features designed to make writing code more efficient, clean, or understandable, but in reality, don't let you do things that you couldn't already accomplish before in another way. So while async and await are new features, new language features, new syntax that we can write, they're just syntactic sugar. They're there to help make our lives easier, to help our code be easier to write and debug and to understand other people's code. Now, what's really happening when this code is run? If we think about our execution stack, the global execution context is executed, then that async function is called. And when an async function is called, if we think about what's happening as it's executing it, it's running through those lines until it reaches the keyword await. So the keyword async tells the engine that we intend to await at least one thing inside this function. What are we awaiting? We're awaiting a promise. Remember, we said that async and await depend on promises as a concept. And this is why. Await will rely on what it's awaiting to be a promise. Now, technically, you could await a different value, but it will still ultimately, essentially be wrapped up in a promise, just like the then function does. When the engine reaches this await keyword then, the execution context is paused. You can think of it as kind of being set off to the side, and regular function invocation and execution continues, and that is going to sit there until the promise being waited for resolves, either fulfilled or rejected. So we imagine perhaps some other function being called, another work happening, and then eventually the promise that the await keyword told the engine we wanted to wait for finishes its work. When that happens, that paused execution context goes back on the stack, and at the point we were awaiting, function execution continues, only now we have that value that the promise represents. And so the rest of the execution of the function can continue. So when we look at our code here, we can see that we're awaiting this promise to be resolved. That means that the code after it kind of acts like what's inside the handling function passed to .then. We have another promise that is again awaited. So this function will pause twice, waiting for both of these promises to resolve, and in the proper order. So why is this so great? Because it takes our code that's dealing with asynchronous processes and makes it as simple to look at and write as synchronous code is to write. And this, as coders, makes our lives easier. This really is a terrific feature of JavaScript. Now, I'll put a small caveat here that async and await depends on promises. And that means that any code that you're dealing with that uses async functions and await also need to be smart in dealing with promises. So one of the dangers of syntactic sugar is that you can just throw on the keyword and think it will work just like you expect. But that's not always true. So be cautious. If you're dealing with some code that uses async and await, remember what's actually happening under the hood. That the function execution is being paused and the workflow continues to the rest of your JavaScript program. That can help you deal with some unexpected behaviors, especially if the rest of your code is not dealing with or waiting on promises. And which one should you use, promises or async await? Well, the answer is if you're using async await, you are using promises. And in some circumstances, you'll use both. Async await is designed to be much easier to read, much easier to write. So personally, I lean toward using async and await as much as I can, but understanding they're just a useful way to write code that deals with promises. We also haven't touched every single aspect of the promise object, and there's other useful functions available, as well as dealing with errors via .catch or try catches inside an async function. But I hope this video has helped you get a proper mental model of what promises, async, and await really are, to help you to write your code and debug your code when you have problems. And that's it. Promises, async, and await in a JavaScript programming language. This has been Don't Imitate, Understand, and I'm Tony Alisea. If you like this video, please subscribe, and also check out the descriptions in the video to look for coupons to my full-length courses. Happy coding!